Hi everyone. My research is about unraveling students' mental models of the apparent motion of the sun by using task-based think-aloud interviews. Why? Well, we know that only few people obtain a deep understanding of apparent celestial motion, despite the fact that we have the chance to interact daily with the sun, and despite formal education in schools or in a planetarium. Most people develop alternative mental models, and we believe those are interesting for educational research in two ways, and I will explain that based on the framework we developed. First of all, a mental model is built on an individual's knowledge structure and therefore reflects the content and coherence of this underlying structure. So, getting a good look of a person's or student's mental model on a certain topic gives us domain-specific insights to improve education. Because when we know what common alternative mental models are, we can look for ways to overcome this. But secondly, these mental models don't just exist. They are dynamic structures that are being constructed and then used to give an answer on a question, make explanations or predictions, but also they can be evaluated. And when a person experiences certain discrepancies, it's possible to revise a mental model. And we believe that gaining insight in how these reasoning processes take place, so how a mental model is constructed, how it's being revised or adjusted, will give us more insight into general learning mechanisms. Now, in this study, we want to look at both aspects, but today I will only talk about this first part. And for this part, the research question we address is as follows. So, what are students' mental models of the apparent motion of the sun? And more specifically, which elements, characteristics of elements, and connections can we retrieve in students' mental models? Which alternative ideas are present? And which of the necessary features are possibly missing? So, in order to give an answer on this question, we conducted individual task-based think-aloud interviews with 16 to 18-year-olds. We chose this age group because our topic is part of their geography curriculum at school. So we asked students to give descriptions and allocentric explanations of the daily, the yearly, the latitude-dependent, and the seasonal changes. The interview started with 6 regular questions based on the Amos test. So, for example, question C. In September, an observer in Brussels sees the sunset in west as shown in the figure, but where does an observer see the sunset in December? Or question D. It's winter, we're in Brussels, and we see the sun here at its highest point, but where does an observer in the side of Spain see the sun at its highest point at that same day? And then we continued with 6 hypothetical questions, such as what if the Earth would not be a sphere but a cylinder? And there we want to see how students reason when some characteristics of the model are being adapted. Students were encouraged to explain their thoughts through words, gestures, sketches, and 3D materials. And we considered their expressions as expressed mental models. Then the interviews were transcribed, and we checked if their mental models obtained the necessary elements, characteristics, and connections, because we believe that there can be alternative or missing ideas at each level, so to speak. For example, to give an answer, a correct answer to this question, you need to be aware of these elements and that they have an orientation towards each other, and that changes in this orientation will lead to changes in what we can observe. But these elements all have certain characteristics, multiple characteristics, and furthermore, they need to be connected in a certain way to make you conclude that and how the Earth's revolution influences the position of sunset. And it can go wrong in multiple ways, as we actually see in our data. Now, in general, we found that not all students are aware of all the observable changes. Students have difficulties in describing or predicting the observable phenomena. Moreover, they are not very certain about their answers. They change their answer sometimes multiple times during the interview, sometimes for the better, sometimes for the worse. And we also see that questions about the changes in sunrise and sunset are more difficult for them. Explaining the phenomena, on the other hand, is even more challenging for students. Their mental models often show missing and alternative characteristics and connections. And also, the students that had exactly the same instruction at school do not necessarily show the same alternatives. So it seems like mental models and knowledge is actively constructed by the individual student. However, students who had different instruction because they had different teachers or different textbooks did show the same categories of alternative characteristics and connections. And those recurring categories are very interesting to us. They're interesting domain specific wise to inform teachers about them so that they can use this information to improve their lessons, but also learning wise. And therefore, we want to investigate further how these are being constructed and revised, which we will be doing in the second part of our study, as you might remember from before. Now, what are these recurring alternative characteristics? Well, I would like to show you some examples of these alternative characteristics and connections that students show in the Earth's orbit, the Earth's axis, and in defining the cardinal directions. I will just show some examples because I won't have time to discuss everything. So, the most common mistake in defining the Earth's orbit is that students show the orbit as highly elliptical, and that most of them use that to explain the seasons. This is something that is well documented in previous research. But there are variations, so there is different reasoning behind this idea. Some students position the sun at one of the foci of the ellipse and assume that when the Earth is closest to the sun that it will be summer. But others place the sun in the center of the ellipse and state that it's summer or winter when we're closest to the sun, depending on the hemisphere we are in, but I don't go deeper into detail uh, about how this is possible. Still, others state that when the Earth is closest to the sun, because of the actual tilt, it is summer. Once a year for the northern hemisphere and half a revolution later for the southern hemisphere. But for them, both winter and summer are on the major axis endpoints. Then there are other students that explicitly show the Earth's orbit as being inclined relative to an imaginary horizontal plane where the sun is in. As a result, Earth is sometimes explicitly shown as being higher or lower with respect to this plane and to the sun. This suggests the natural tendency to attribute notions of up and down to the ecliptic plane as well. Now, according to the tilt of Earth's axis, quite some students show a change in the actual tilt throughout the year. This has been documented in previous research, but there are also variations to this general idea. Also, the origin of these alternative IDs is not always the same. For some students, they seem to be pre-existing IDs, while others develop it while interacting with the materials. For instance, when you look at the top left figure, the student holds the axis and moves the Earth around the sun, simply without paying attention to the orientation of the axis. So I ask them to demonstrate how Earth revolves the sun, and they do this, without really considering that their axis is changing its orientation. Still, others seem to construct this idea as a response to an experienced cognitive dissonance. For example, as illustrated in the bottom figures, some students know how the tilt should look in winter and summer, but they're not sure what happens in between, and then they resolve this issue by systematically moving the axis between summer and winter orientation, sometimes by just going up and down, sometimes by even turning the axis around. And then we also experience that many students struggle to define cardinal directions on the horizon plane. Most of them do not even explicitly mention a horizon plane. Moreover, finding the direction of sunrise and sunset with this system, even if it's correct, often proves challenging for students. So, this is how it should be, with the north aligned with Earth's north pole and a horizontal viewing line to the sun. However, some students do not align their north if the Earth's axis is tilted, as you can see here in the top figure, or they look to the center of the sun, which is also wrong. But there are also students that do not define their coordinate system based on the observer, but take the Earth as a center of the cardinal directions. Sometimes the observer's location in that system is considered the direction of rise or set. And in this way, they explain differences in Belgium and Spain. So that's what you can see in the top figure. Sometimes, in defining their cardinal system, they assume that the Earth needs to be in the direction of the south, and then they fill in the other cardinal directions around the Earth in the order that they know. So that's what you can see in the bottom figure. Now, one of the limitations of our study is that all the assumptions we make about students' mental models are based on our interpretations of their expressions. We are very well aware of this limitation, but still we believe that our findings are and will be useful. So thank you for your attention. If there are any questions, I will be very happy to answer them.